Hello there guys. Welcome to the WPF Chronicles series. In this video, we are going to understand the object hierarchy of controls in WPF, and side by side, we will see the architecture of WPF as a framework. Most of the managed code implementation of the WPF can be found within these three components: window base, presentation core, and presentation framework. Internally, the window base routes the rendering instructions to the unmanaged component, core. So, we can consider one unmanaged and two managed components, which constitute the architecture of WPF. Although this looks a simple three-component architecture here in this picture, it is quite complex and thoughtfully designed. To understand which component contributes what functionality, let's take an example of a WPF button as a control and then thoroughly see how it is derived from the very root type, known as DispatcherObject. Before we talk about DispatcherObject, let's get introduced with the concept of dispatcher. A dispatcher, which is defined in the window-based DLL, provides services for managing the queue of work items for a thread. Sounds complicated? Well, the thing is that a running application has a thread associated with it, which is managed by the operating system. Any application may have more than one threads running. For a WPF application, there is main thread, sometimes called UI thread, because all UI-related tasks are executed on this thread. Dispatcher is the object which is responsible for managing various tasks to be executed on the UI thread of a WPF application. Dispatcher maintains a prioritized queue of tasks to be executed on the UI thread. It means some tasks of higher priority are run before other tasks of lower priority. The dispatcher object of any WPF application can be accessed through the property application.current.dispatcher. Any WPF application has only one dispatcher associated with it. It is created by the runtime, and as a developer, you don't have to create it, but only access it when needed. DispatcherObject is an abstract class. This class, or the classes derived from it, represent an object associated with a dispatcher. The application class derives from DispatcherObject. The property application.current.dispatcher is not defined in the application class itself, but rather contained in the DispatcherObject class, and it is inherited by the application class. DispatcherObject belongs to the window-based component of the WPF architecture. As the object class is the ultimate base class of all types in C#, you can consider DispatcherObject to be the ultimate base class for all the controls in WPF. What does DispatcherObject provide? It provides checkAccess and verifyAccess methods. The checkAccess method determines whether the calling thread has access to that particular control on which this method is called. If calling thread has access, this method returns Boolean true value. Let's see this with an example for better understanding. In our main window.xaml, we have a button. Let's give this button the name attribute value so that we can access it in code behind. Set x:name equal to my button. And now let's switch to code behind file. Here, we can use the button with its name property, myButton, and then type checkAccess. You will notice that checkAccess method is not listed in the IntelliSense completion list. You have to type it manually. And because this method returns a bool value, we can assign the result to a bool variable. Otherwise, we can directly call the method in the if statement. And if the calling thread has access to the button, then we can set some property of the button here. Let's say the content property. Let's set the content property equal to my button. Okay, so what if checkAccess method returns false? In that case, we'll have to delegate setting content property to the dispatcher of the current application. Let's write this part in the else block. We will call the invoke method on dispatcher and pass this statement, which assigns content property to the button as a lambda expression. In this way, whether or not your button's content is set on the UI thread, it will be executed for sure, without an error. Getting back to the DispatcherObject, what does verifyAccess method do? When you call verifyAccess method on any control, it enforces that the calling thread has access to that control. If the calling thread is not the UI thread, then it throws an invalid operation exception. Now try to imagine the scenario where you may use verifyAccess method. And let's turn back to object hierarchy. The next in the hierarchy after DispatcherObject is dependencyObject. The DependencyObject class enables the derived types to use some special services provided by the WPF property system. Because WPF controls are derived from this DependencyObject class, they can own dependency properties. Dependency properties are the reason controls can support some WPF features such as data binding, style, triggers, animations, etc. Dependency properties is a huge topic, and it is covered in details in further videos of this series. For now, just remember that DependencyObject class is defined in window-based DLL, and it enables derived classes to own dependency properties. The next class in the object hierarchy is Visual. Now we have moved from window-based DLL to presentation core DLL. Visual is the first class in this object hierarchy, which is present in presentation core, that gives derived classes ability to render. Visual class provides core-level functionality for rendering visual elements on the screen. Rendering means drawing or painting the desired shapes on the screen. Visual class provides following functionality. Render persisted serialized drawing content of a visual. Perform any transformations on the visual. Transformations means setting offset, rotation, flipping, etc. Provides clipping support for a visual. Provides hit testing, which means determining whether a point is contained within the bounds of a visual. Provides ability to determine the bounding rectangle within which a visual is rendered. While you may use a very few concepts of these as an application developer, it is very useful to understand these concepts if you want to create a new control from scratch, because visual class can be considered as the entry point for creating new controls. Next class in the object hierarchy, which is derived from visual, is UI element. UI element is also present in the presentation core DLL, and it provides some core-level functionality to the derived control classes. Like visual class provides support for rendering a control, the UI element class provides a control's layout characteristics. This classes contains a number of virtual methods, which can influence how the layout of a control and its children is rendered. UI element class also defines the input and focusing behavior of a control. This includes how the control responds to keyboard and mouse inputs, touch or stylus inputs. Also, whether a control can have keyboard focus, and does it or any of its children have the keyboard focus. UI element class provides ability to render a control as a child of another control. It also contains logic for sizing and positioning of the child controls. This class supports routed events, which is a very important concept about how events are raised in the WPF user interfaces. Sure, we will deep dive into those concepts later. UI element also supports some aspects of WPF animation system, because of which it is possible to animate some properties of the WPF controls. UI element class provides a lot of behavioral functionality to a control. However, this is mostly abstraction of that functionality. The actual implementation is provided by the next class in the hierarchy, derived from UI element, which is framework element. This class is present in the presentation framework DLL. Beginning from this class, the framework-level implementation of the WPF architecture starts. When using any control in XAML, you will set many properties of that control in XAML, like height, width, horizontal alignment, vertical alignment. Give it a name with x:\name attribute. All these properties are defined in the framework element class and are inherited by any control. So framework element class basically exposes properties which define how a control is placed on the UI. Framework element class also provides exposure to features which are helpful to animate the properties of a control through the method called begin_storyboard. Framework element class introduces a very important thing called data binding. Data binding helps to bind some properties of a control to some data directly, and the UI updates automatically when there is change in the data source. Framework element class also introduces another very important thing called style. Using styles, we can share the set of properties across instances of a control, which define how a control looks. So, framework element provides concrete implementation to the policies provided by UI element class in an easy-to-use way, and also introduces new policies. Now we will move to the next class in the hierarchy, which is derived from framework element, called control. The control class exposes some properties like background, foreground, padding, border-related properties, border brush and border thickness, font-related properties, font family, font weight, font style, etc. Using these properties, the look of a control can be customized. More importantly, the control class exposes a property called template of type control template. By setting the control template property, the look and feel of the control can be customized from scratch. The other properties provided by the control class, such as background, padding, etc., can be inherited by this control template. We will move down the object hierarchy for now, and keep the topic of defining a control template for future video. The next in the hierarchy is content control. The content control class exposes a property named content. The type of this property is object. So basically, this content property facilitates setting content of a control, which inherits content control class. The content can be of any type, because it is of type object. If we consider a WPF button control, we usually set the content property's value as a string. However, you can set the content to an image or any complex object if you want to. Note that content control can have only one child, that is, only one object as the content. Apart from content property, this class exposes other properties such as has content property, which has value boolean true if content property is set. Content string format property, which specifies the formatting of text content and works only if content is of string type. Content template property of type data template, which defines how to represent the data on UI. Data template is an interesting and important topic, and we'll cover it in more details in future videos. We are now close to reaching the button control in this object hierarchy. The next class which inherits content control is button base. Button base class, as its name suggests, is base class for all types of buttons in WPF. You might wonder, are there many types of buttons? Yes, there is button, repeat button, toggle button. Further, the column and row headers of a data grid and column header of grid view are also the buttons derived from button base class. Now let's discuss what button base class provides. It exposes a routed event, named click event, to identify when a button was clicked. This event is most commonly handled in code behind, to write some logic you want to execute when a button is clicked. Button base class also exposes properties, command parameter. These properties are often used in viewModel class to handle the button click logic when using MVVM pattern. And of course, commands will be discussed in great details afterwards. Button base class provides some event handler methods to handle input events, such as key up, key down, mouse enter, mouse leave, and many more. The button class, which is derived from button base, has very little implementation in itself. It exposes a property, isDefault. If you set isDefault property of a button to true, the button's click logic or command logic will be executed when enter key is pressed. Likewise, it exposes a property, isCancel. If you set isCancel property of a button to true, the button's click logic or command logic will be executed when escape key is pressed. Button class also exposes the isDefaulted property. This is a read-only property. It returns true when the button's isDefault property is set to true and the button itself does not have focus. Because if the button has focus, then the enter key will be handled by an event on key down, and value of isDefaulted will be false in that case. So, next time you edit a button's properties in XAML, you know where these properties are coming from. Margin, horizontal alignment, and vertical alignment are coming from framework element. Content property is coming from content control, and isDefault property from the button itself. This explains why you can set certain properties on multiple types of controls in a consistent way. For example, horizontal alignment property can be set on a button and on a text block as well, because both inherit from framework element class. That's all for this video. If you think these videos are helpful, please hit the like button. Also, if you haven't already, subscribe to the .NET Study Room channel. I'll see you soon in the next video.